The principle of mathematical induction is a very powerful and effective technique of mathematical reasoning, or a way of proving propositional functions that involve integers. One of the weaknesses of the principle of mathematical induction is that it is unable to generate the propositions. So the idea is that we are given a proposition and we are trying to establish it by using the principle of mathematical induction. In this way it is very effective, and sometimes it gives a very elegant and short proof for very important mathematical propositions. So the two-step process that we discussed earlier can be also explained as a three-part process. For example, the first step is the base step, which means that we try to establish that the given proposition is true for the most basic value, for example n equals 1, and this is referred to as a base case. Sometimes the base case is also n equals 0 or any other starting value of n, but mostly for this chapter we will assume that n is equal to 1 is the given base case for our statement. In the second part of principle of mathematical induction, we assume that the statement or the propositional function is true for a given value of n, let's say n equals k. So we make this hypothesis or assumption about the proposition that it is true at a given step or for n equals k. And then in the last part of principle of mathematical induction, we use induction to establish the truth of the same proposition for the next value of n, which is k plus 1.